Grok 4.5, Claude Fable 5, and Gemini 3.6 all get thrown into the same coding conversation, so I ran the same 5 tests on all 3. Cost, benchmarks, speed, context limits, and deployment. The biggest surprise is that the model everyone calls the cheap option actually loses the sticker price fight on input tokens and still wins the category anyway. By the end of this video, you'll know exactly which one to point at your codebase and which one to leave alone until it publishes a single number about pricing. Pick the price your model for a coding agent running all day, and the bill catches up to you fast. So let's look at what each one actually charges. Grok 4.5 runs 2 ports per million input tokens and 6 per million output tokens, with a cache rate of just 0.30 per million dollars. Gemini 3.6 undercuts it on the front end at $1.50 per million input tokens, but flips to $7.50 per million on output. Claude Fable 5 publishes no pricing figure at all for input, output, or cache. On sticker input price, Gemini 3.6 wins clean. $1.50 per million against Grok's 2.0 is a real 33% gap in Gemini's favor. But coding agents don't just take tokens in, they generate a lot of tokens out, and that's where this flips. Grok's $6.0 per million output beats Gemini's $7.50 per million by 20%. And for any agent that's writing code rather than just reading it, output is where the real spend lives. Google's own scale example puts a 10 million input, 2 million output run at roughly $30 on Gemini 3.6. Run the same volume on Grok 4.5 and you land around $32, nearly identical. So on raw sticker math, it's basically a coin flip. What breaks the tie is that $0.30 per million cache rate. If you're running an agent loop that resends the same context over and over, which is exactly how coding agents work, Grok's cache pricing turns into a fraction of what you'd pay elsewhere. Grok 4.5 takes this test. Claude Fable 5 sits this one out entirely because there's no number to score. That's a real transparency gap if you're trying to budget a production coding agent around it. My name is Brian, and I spend most of my week digging through AI products, benchmarks, APIs, and pricing pages to figure out where these tools actually differ. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. Cost only matters if the model can actually do the job, so here's the benchmark that decides that. On SWE Bench Verified, the most cited real-world coding benchmark out there, Claude Fable 5 scores 95%, according to official docs on Goldie Bench's model page and Vellum's leaderboard. That's an 8.4-point gap, and it's the clearest single number in this whole comparison. Gemini 3.6 doesn't have a directly comparable SWE bench score, but on Deep SWE, an independent test, it scores 49%, a distant third behind both. Claude Fable 5 also posts an 8.10 out of 10 average on the Goldie Bench Fixed Task Suite, a number neither Grok nor Gemini has a comparable figure for. And on a head-to-head inside Goldie Bench specifically against Grok 4.5, Fable 5 wins 20 tasks to 17. 20 to 17 is a narrow edge, not a blowout. Claude Fable 5 also shows up strong on 2 other benchmarks worth naming. 84.3% on Terminal Bench 2.1 and 85% on OS World Verified. Neither Grok 4.5 nor Gemini 3.6 has a reliable published figure to compare against those two, so I'm not scoring those as wins, just noting that Fable 5 is the only one of the 3 with a full, measured coding benchmark suite behind it. Claude Fable 5 wins this test clearly. If you're optimizing purely for raw coding capability and you don't care what it costs, this is the number that should decide things for you. Grok 4.5 scores 86.6%, a vendor-claimed figure. That's worth pausing on because it's a real, measured, direct comparison rather than two separate leaderboard runs, and it's a lot closer than the 95 versus 86.6 headline makes it look. A model that codes well but takes forever to respond breaks the feel of an agentic workflow, especially once you're chaining calls. Grok 4.5 runs somewhere between 91 and 119 tokens per second, independent tested. Gemini is running roughly 2.6 times faster on raw output. Time to first token is a lot closer. Grok 4.5 sits around 13 to 17 seconds, and Gemini 3.6 sits around 12 to 15 seconds. That overlap means it's basically a coin flip on latency. The two ranges nearly sit on top of each other. Claude Fable 5 publishes no throughput or time to first token figure at all, so this test comes down to a two-horse race. Gemini 3.6 takes it on the strength of that 2.6 throughput advantage. If you're generating long files or running high-volume batch jobs, that speed gap is the kind of thing you feel every single day, even if the coin flip latency number doesn't move the needle much. On output throughput, Gemini 3.6 puts out roughly 300 L4 tokens per second, community reported. That's not a small gap. Stick with me because the last 4 tests are where this decision actually flips. Hit a context ceiling halfway through a big codebase and you're stuck splitting files and reprompting by hand. Gemini 3.6 ships with roughly a 1 million token context window, according to vendor documentation. Grok 4.5 caps out at 500,000 tokens. That's a clean 2x gap in Gemini's favor, and it matters most the moment you're trying to feed an entire repository into a single call instead of chunking it yourself. On max output per call, the gap narrows. Gemini 3.6 tops out around 65,000 tokens, and Grok 4.5 sits in a range of roughly 32,000 to 64,000 tokens, depending on the request. That's close enough to call a marginal win for Gemini, not a decisive one. Claude Fable 5 publishes neither number, no context window figure, no output ceiling. Gemini 3.6 wins this test on the strength of that double context window. If your work involves long code bases or documents that need to sit in memory all at once, this is the test that should carry the most weight for you specifically. There is a real caveat on context and output limits worth naming before we score it. For anyone trying to plan a long agentic run in advance, that's a real blocker, because you genuinely don't know where the wall is until you hit it. The best model on paper is worthless if you can't get it running where you need it. Grok 4.5 is confirmed on xAI's own API only, not yet on Azure or Bedrock, with EU availability still pending. On modality, Gemini 3.6 handles text, image, video, audio, and PDF input, according to official documentation. Grok 4.5's modality matrix isn't independently confirmed, so I can't score it as a win, just as an open question. Claude Fable 5 has no published deployment or modality data at all. Neither Grok nor Gemini offers a self-host option, so this test really comes down to reach and flexibility, and Gemini 3.6 takes both halves. It wins deployment reach on the strength of being closed but broadly documented, and it wins modality outright on that 5-format input list. Gemini 3.6 is also API only and fully closed, but it's the more capable of the two on what it can actually accept as input. That's the widest range of the three by a clear margin. Grok 4.5 wins on cost, taking the output price test and the cache rate advantage that makes iterative agent loops cheaper over time, and it holds a respectable 86.6% on SWE bench verified for roughly a third of what Fable 5 likely costs, even though Fable 5 never actually confirms that price gap in writing. Claude Fable 5 wins coding benchmark performance outright, 95% on SWE bench verified, an 8.10 average on Goldie bench, and a narrow but real 20 to 17 head-to-head edge over Grok 4.5. The trade-off is that it publishes no pricing, no speed figures, and no deployment or modality details, so you're taking its coding lead on faith when it comes to everything else. Gemini 3.6 wins speed, context, and deployment, roughly 304 tokens per second, a 1 million token context window, and the widest input modality of the three. Its weak spot is coding itself, a 49% deep SWE score that trails badly behind the other two. If you want the best raw coding quality, and cost is genuinely no object, Claude Fable 5 is your pick, full stop, because that 95% SWE bench score and the 20 to 17 head-to-head edge are the clearest wins in this entire comparison. But for most people, Building coding agents that actually need to run at volume. Grok 4.5 is the default. It delivers 86.6% on SWE bench verified, at roughly half the presumed cost of Fable 5. And that cache rate of 0.30 per million tokens is the difference between an agent loop you can afford to run constantly and one you have to ration. Here's what the sticker price never tells you. That $2 input and $6 output rate for Grok 4.5 only holds at standard processing. Turn on priority processing and both rates double to roughly $4 and $12 per million tokens. And if your agent uses Grok's web search tool, that's billed separately at $5 per $1,000 calls. Add those two things together, and the model that won the cost test can end up costing more than the one it beat. If you want to see how these same three handle a completely different job outside of code, check the next video in this series because the rankings do not hold once the task changes.